All right, so now what we're going to do, we're going to actually do an example problem, a two-dimensional kinematics or projectile motion problem. And you'll see, I mean, it's very, very similar to what we did in Chapter 2, you know, the pictorial representation, the whole bit is very, very similar. Okay, a ball is thrown with an initial velocity of 10 meters per second at an angle of 32 degrees above the horizontal from the top of a 40-meter hill. What is the velocity, speed, and direction of the ball when it hits the ground? Now, by the way, if this were an exam, they probably wouldn't say speed and direction. They just assume that you know that velocity, speed, and direction. So of the ball when it hits the ground, and we talked about this before, right? It's, you know, it's right before it hits the ground, right? Okay. So we want to draw the pictorial representation and solve the problem. So here we go. Okay. All right, so coordinate system. Again, one of these days we're going to change that. So, and okay, so we're going to draw the silly thing, right? So I'm not going to draw the motion diagram anymore. I think we don't really need that anymore. But if you want to, that's perfectly fine. So that's the ground. So here's the hill, right? Okay, so what would be a logical place, or where would be a logical place about the origin? It doesn't really matter, once again. I'm going to put it at the top of the hill. So there's my great straight line. So there's the origin right here. And how many points do I need? Well, you know, just initially, you know, the initial point and the final point, because nothing's really going on. This is just projectile motion, right? Free fall. And so, you know, okay, so here's my V0. And then, you know, it's going to make a nice parabola, right? Okay. All right, so this here, x0, y0, v0, x, v0, y, t0. And we're at an angle. So here, x1, y1, v1x, v1y, t1, and a sub y equals minus g. Okay, so, you know, it's more variables, but it's okay. All right, so now, again, this is our origin. Okay, so x0 equals y0 equals t0 equals 0. So x0 equals y0 equals t0 equals 0. All right, now, they give us that the velocity is 10 meters per second, but, you know, we have to do everything. We have to get an x component and a y component of the velocity, right? So you just got to do it. So v0x equals v0 cos theta, which is 10 meters per second times cosine 32. And that comes out to be 8.5 meters per second. And v0y equals v0 sine theta. So that's 10 meters per second sine of 32. And that comes out to be 5.3 meters per second. Okay, so let's see, x0, got it. All right, now we're over here, all right? Okay, x1, we don't know. Y1, what's y1? It's just 0. So, wait a second. That would have been really bad. What's y1? What's right here? Right, so this is the origin. This is the coordinate system. The hill is 40 meters high, so what's y1? It's minus 40. And again, you know, just looking at this reminds me that I better have a minus sign there. So it's good. Okay. v1x, remember this is just projectile motion. So the horizontal velocity never changes. So v1x is the same thing as v0x. All right, now v1y, do I know v1y? No, in fact, that's what I want. So v1y, that's what I want. Okay, and t1, I don't know. All right, now, let's see, what do we know? Okay, so let's go back to the kinematic equations, wherever they are. There they are. Okay, so look, we don't have any time information. We want to get a velocity. Well, we don't have any time, so goodbye, goodbye, right? Okay, now this looks good, but let's hold on, let's see, right? So we want to get v1y, that's this. So do we know v initial y? Right there, right there. We know v initial y. Do we know delta y? Yeah, we know delta y. It's 40 meters, right? Or minus 40, however you, right? So this is the equation. So again, you know, after you do all this, you just have to kind of look at what you have and what you don't have, or what you know and what you don't know, and you have to choose the correct equation. That's really all there is to it. All right? So we're going to choose that bottom one on the right. So v1y squared equals v0y squared minus 2g y1 minus y0, right? Because that's what delta y is. Delta y is y final minus y initial. Okay, but what's y0? y0 is 0, so we can just forget about that, right? There. We just have that. All right, so therefore, v1y equals plus or minus square root of this thing, v0y squared minus 2gy1. Okay, now it's going down, right? Come on, come on. Okay, so it's going down, so what are we going to choose for the plus or the minus? We're going to choose the minus. All right, okay, we're going to choose the minus. Now you just plug in. So minus, okay, v0, okay, so now look, everything we need is right in front of our pretty little face, right? v0 is 5.3 meters per second squared minus 2g y1, where's y1? Where to go? Who are you? Minus 40. Okay, you get a minus and minus, which is a plus. And so you do that, and you get 28.5 meters per second. Okay, does that seem reasonable? Well, yeah, I mean, it's not crazy, right? It seems fine. Not too high, not too low. Got the right units, you know, right? Because it's a square root of a meter squared over a second squared, so we got the right units. Everything looks good. Okay, now that's v1y. Well, that's great, but we want to know the final velocity. Well, the final velocity has an x component and a y component, right? So we are not done yet. Okay, so this is v1y, right? So let me write that somewhere. So v1y is negative 28.5 meters per second. Well, by the way, sometimes on the exams, you know, the people who write exams are rotten. Just kidding. The people who write the questions for the exams, you know. So sometimes they have things like this as a possible answer. It's kind of rotten, right? Because, you know, you get that, you look at it, oh, I'm done. Well, you're not done. Okay. Okay, so now we have to get v1. So the magnitude of v1, right? The magnitude of v1 is v1x squared plus v1y squared, square root of, you know. So let's see, what's v1x right here somewhere, right there. So 8.5 meters per second squared. Okay, we're going to square that so we don't care about the minus sign. 28.5 meters per second squared square root of. You do that, you get 30. Wow, nice number. 30 meters per second. Okay, that's the speed. Now we want the direction. So we might as well draw a picture. I think it's worth it. So V1x is 8.5 meters per second. And this is not a scale drawing, right, because I ran out of room. Sorry, V1x is 8.5, V1y is 28.5 down. Second down. So here's the angle, right? So how do you get the angle? Well, you know the opposite, you know the adjacent, that's tangent. So theta is tan inverse opposite over adjacent. And you do that, and you get 73.4 degrees. All right, that's how you do it. Now, by the way, if this were a question on the test, you know, they would have to say, you know, like what is the angle relative to the horizontal or something like that. Because, you know, you could have gotten this angle, right? I mean, but so they'll always specify, so you don't have to wonder if it's this angle or if it's that angle. Okay, so let's just review it. You know, coordinate system, pictorial representation, label everything to death, write everything that you know, but you know, you have to do a little bit of work, right? Because you have to get V0x and V0y. You got to do that. What can you say? And then you just choose your correct equation, plug it in, see if it's reasonable. Is the angle reasonable? Well, yeah. I mean, you know, it's kind of normal, right? Okay. All right. So that's really all there is to it. Now, I do have to say one thing though. This was a nice one because, you know, we wanted to get the velocity, and we were able to get it, you know, the V1y right away, right? We didn't have to find like time first or something else. And again, that's kind of not usual. Usually you have to find something else before you can actually find what you're looking for. So this is a nice, easy one. It's going to get harder. Okay. All right, so I'm sorry to keep saying this, but if we were in class, I would show you this, then I would leave the room, seriously, and I'd have you work in groups and figure it out. Because what I've learned is that, you know, you can watch me all the day long, but if you don't do it yourself, you're not going to learn how to do it. All right? So what I'd appreciate, and if you want to learn, you will read it and pause your video and do it yourself. And don't be afraid if it takes a half an hour. But you will figure out, when you do it yourself, what you understand and what you don't understand. Okay? So pause your video and do it. All right, so we will do it. Okay, soccer player kicks the ball. Ball is the foot. Okay, so all we have to do is find the speed. Oh, that's not cool. Okay, now notice it says the answer is not 19 meters per second. What does that imply? You know, what does that imply? I mean, here's the ground, okay? So let's just say the ball was there when it was kicked, all right? After it's kicked, it's free fall, agree? So, you know, if the goalkeeper caught it on the ground, what would be the speed? 19 meters per second, agree? Because of the symmetry, remember we had talked about that. But the fact is it's not 19 meters per second, so what does that imply? It means that the goalkeeper caught it somewhere above the ground, okay? So you want to remember all those little symmetry hints. All right, here we go, let's do it. So plus, plus, minus, minus. There's no hill, so that's nice. Okay. So again, how many points just 2 points, right? So here's our first point. So x0, y0, t0, v0x, v0y. That's v0 at some angle. Okay, now our second point is who knows where, up there somewhere, right? We don't know, we don't care, right? Well, we do care, actually. But, all right, so x1, y1, t1, v1x, v1y. Again, what's A? So A sub y equals minus g, because it's free fall or projectile motion, whatever you want to call it. Okay, so there you go. All right, so it's going to be a nice parabola. I'm not going to draw that. Okay, let's see. So we'll make this the origin, might as well. All right, so x0 equals y0 equals t0 equals 0. v0x equals v0 cos theta, which is 19 meters per second times cosine of 32. What's the 32? And that is 16.1 meters per second. Okay, v0y equals v0 sine theta, so it's 19 meters per second, sine 32, and that is 10.1 meters per second. Okay, so I got all 5 of these things. Great. Now I go up here, right? Do those. Okay, so x1, let's see, x1, the goalkeeper is 29 meters from the soccer player, and we said the soccer player is the origin, so it's 29. Okay, that's cool. 29 meters. Okay, we already discussed the fact that we don't really know where the goalkeeper caught the ball, but we know it's not on the ground. So we're not going to say 0. So we don't know. We don't know the time. We know that v1x equals v0x, because it's projectile motion, right? No acceleration in the horizontal. v1y, we have no clue, right? Okay, so find the speed. Well, the speed is going to be a x component and a y component. So we know the x component, so we just need to find the y component. Then we'll just use Pythagorean theorem. All right, now here's the cool part. All right. Okay, let's see. We want to get a v1, but we don't know the time. We can't use that. Well, that doesn't help us because there's no v in it. Now, so you think, oh, maybe we can use that. But we can't use that because we don't know delta y, right? We don't know what the y final is. So we're up a creek without a paddle, right? Well, not really. Okay, so this is kind of a typical problem, but this is not so bad though. Okay, so so this is hopeless. So, but maybe we could use that if we could figure out the time. If we could figure out the time, we could do it. Now wait a second. Wait a minute. Look at the question. The horizontal velocity is 16.1 meters per second. It travels 29 meters in the horizontal direction. Well, if we know the horizontal direction, the horizontal distance and the horizontal speed, what can we get? The time, right? The time, okay? So there you go, all right? So, if you want to look at the equations, it's this equation, right? But you don't really need it, I hope. Because this is 0, this is 0. So it's just distance equals speed times time, right? Distance, I mean, you ought to know that, right? Distance equals speed times time. Okay? So, ha-ha! So we can get the time, and then we can do the problem, okay? So, awesome. So the distance equals the speed times the time, all right? But look at, it's x, it's not y, you know? Sometimes for some problems you'll use y. So it's the horizontal distance equals the horizontal speed times the time. So therefore, the time equals the horizontal distance over the horizontal velocity. So x1 is 29 meters. v1x is 16.1. And that is 1.8 seconds. All right, so this is a real typical problem, you know? I mean, you look at the equations initially and say, oh my gosh, I'm dead, I can't do it. But then you got to look at it and you got to start thinking, oh, maybe I can get the time, all right? So this is kind of cool, right? And you got to recognize that. You got to train yourself to recognize that. As soon as you see that horizontal distance with horizontal velocity, bingo, you got to tell yourself, aha, I can get the time. All right, so now I know the time. Yippee! So now I just use this, the first one, right? v1y equals v0y minus gt1. That's the very first equation. Now, this is wonderful, because I know everything here, right? So v0y, where'd that go? Right there, 10.1 meters per second, minus g is 9.8 meters per second squared. T1 is 1.8 seconds. Notice I have a meter per second. That second's going to kill one of those seconds. I'm going to get a meter per second. And so it's going to be, now look, it's 10 minus, and this is bigger than 10, so it's going to be negative. It's going to be minus 7.5 meters per second. So what does that imply? Did the goalkeeper catch the ball when it was going up or when it was going down? Obviously, if v1y is negative, the ball was going down. So that's where the goalkeeper caught it. Right, now we want the speed. So we want the magnitude of v1. So that's v1x squared plus v1y squared, square root. So v1x is somewhere 16.1 squared. v1y, we just figured it out. I don't care about the negative because it's getting squared. And we square root the whole thing. And we get 17.8 meters per second. There you go. So there's just, again, this is a more realistic problem because we had to figure out the time before we could use the kinematic equation. Okay, let's quit.